Assalamu alaikum everyone. Today you will get information about anatomy and physiology of basal ganglia. First of all, we shall talk about the anatomy of the basal ganglia. That's a gross section of the cerebrum, and there is the main structures drawn here for you. First one is two types of ventricles. First one is lateral ventricle, second one is third ventricles, located here and located here respectively. Okay, next structure is nucleus cardatos. Nucleus cardatos located near to the lateral ventricle through the whole part of the cerebrum. And that's large structure is thalamus and substance nigra, hypothalamus, and subthalamic nucleus is a small one but play major role in basal ganglion function. And there is lentiform structure. Lentiform consists of putamen in the black color and globus pallidus. Globus pallidus externus in blue color and internus in red color. And there is a reason for calling as a lentiform. Together, both structures looks like lens. Okay, that's lens. Sorry. You know, the lens is some kind of physical part, optic part of our visual system. Together, globus pallidus and the putamen looks like lens, and so we call them as lentiform. And between the nucleus cardatus and putamen located some kind of strias, so we call putamen and nucleus cardatus together as a striatum. Putamen's function is motor function, and in a cognitive function, caudatus play an important role. Second part of our lesson is devoted to the physiology of the basal ganglion. First of all, I should talk that some kind of circuits available between motor cortex, basal ganglion, and thalamus. Okay, these circuits play an important role in our motor function. Okay, and there is two pathways, direct pathway and indirect pathway between this circuit. Let's first of all talk about the direct pathway. Direct pathway initiates from two parts of the cerebrum. First one is cerebrum, that's hemispheres, sorry, and the second one is substance nigra pars compacta. Okay, both of them conduct its stimulatory or excitatory impulses to the putamen. In the putamen receives the stimulatory impulses from the motor cortex via glutamins, and from the substance nigra pars compacta as a dopamine. Substance nigra pars compacta stimuli the putamen via dopamine 1 receptors. Via dopamine, okay? And the next pathway, next direction is directed to the globus pallidus internus. And the putamen act on the globus pallidus internus as an inhibitory via 𝙰𝙾𝙼𝙾𝙃 acid. And main function of the globus pallidus interna is inhibiting the thalamus. You know, when the inhibitor inhibited, that means that plus. It means that the thalamus is out of inhibition. It means that thalamus can cause its positive effect to the motor cortex. As a result, the motor activity will increase. Okay, will increase. And the next pathway is indirect pathway. The result of the indirect pathway is motor activity decreasing. The indirect pathway initiated mostly from the hemispheres via two ways. First way is glutaminergic way to the putamen. And when the hemispheres stimuli and conduct its excitatory impulses to the putamen then conduct its inhibitory impulses via 𝙰𝙾𝙼𝙾𝙃 acid on globus pallidus externus. Globus pallidus externus' main function is inhibiting subthalamic nucleus. Okay, subthalamic nucleus is inhibited via globus pallidus externus. When the motor cortex stimuli the 𝙱𝙾 inhibit globus pallidus externus. When the globus pallidus externus inhibited, it means that subthalamic nucleus is out of inhibition. Okay, it means that subthalamic nucleus can act its function properly. Subthalamic nucleus have two targets. First one to the globus pallidus internus. Second one is substantia nigra pars reticulata. Both of them together inhibit the thalamus. Subthalamic nucleus activate the globus pallidus internus and substantia nigra, and as a result, both globus pallidus internus and substance nigra inhibit thalamus, and the thalamus couldn't perform its motor cortex activatory role. It means that the motor activity will decrease. All of the most important and necessary information is all for you. Thanks for listening and watching. See you next time.